All right, 3.4, graphs and transformations. When the rule of a function is algebraically changed in certain ways to produce a new function, then the graph of the new function can be obtained by a geometric transformation. A parent function is a function that has kids. Just kidding. Parent function is a function with a certain shape that has the simplest rule for the shape. For example, f of x equals x squared is the simplest rule for a parabola. Every other parabola comes from that original parent function of x squared. I don't think that this is very important, which is why it's in all capitals. Just kidding. Obviously, it's important. It's as important as liking and subscribing. You should memorize the shapes of the parent functions. Our first parent function is the constant function. That is one like f of x equals 1. It's just a number on the right-hand side. When we graph that, it's just a horizontal line. It goes through y equals 1. That is a constant function. That takes us to the identity function, which is f of x equals x. Now, somebody might have said that the first one was a straight line, right? And that's where our clarification should be. It's a horizontal line, not a straight line. Because this line is also straight. There's no curve in it. It's straight. Even though it's on a diagonal, f of x equals x goes up 1 over 1, up 1 over 1, up 1 over 1. It's on a diagonal, but it's straight. There's no curves. So what's your descriptions of how you describe these functions? The constant function is horizontal line. The f of x equals x is just an identity function, up 1 over 1, still straight line, like and subscribe. Next is the absolute value function. The absolute value function is f of x equals the absolute value of x. This one is a v. Comes down to a point. It goes up to a point symmetrical about our vertex, which means that if I go up 1 over 1 to the right, I'm going up 1 over 1 to the left. If I went up 2 over 2 to the left, I would go up 2 over 2 to the right. So it's going to be symmetrical about the y-axis. Next is the greatest integer function. This is f of x equals bracket x. Now the greatest integer function is going to be going in steps. This says that every number that's between -5 and -4 is the greatest integer that's less than the number. So if I had -4.5, the greatest integer that's less than -4.5 is -5. So that's why my line is at -5 for each one of those. -3.2, the greatest integer that's less than -3.2 would be -4. Coming over to this side, this is like if, say, somebody owed you $2.50, right? But you didn't have any pockets, you didn't want to carry the change, all you wanted was the bills. This would be like you asking them to just give you $2 instead. Like, just keep the change, give me the $2. So that any number that's, even though it's $2.50 that you're owed, they're giving you the lesser integer or the lesser whole number. The greater integer function rounds down every decimal. 3.8 rounds down to 3. So even though my x would be 3.8 here, be close to 4, even though it would be close to 4 here for my x, the y is just going to be 3 because it rounded it down. That's why it's a horizontal line that goes between 3 and 4. It's an open circle at 4 because as soon as I hit 4, I'm jumping up to the next one. 4 is a whole number. It's the least greatest integer that's less than or equal to 4. So if you owe me $4, I'm not going to say, oh, well, keep the change, just give me 3. No. When I hit 4, you're going to give me all $4. Yeah, we won't see too many of these. So our next is the quadratic function, which is f of x equals x squared, and that forms a parabola. Next is f of x equals x cubed. Starts in the negatives, comes up and to the right, goes through 0, 0, and then curves up and to the right some more. I would have lost it. If I would have lost the recording, then I would have lost it. Not the recording, my mind. Reciprocal function is next. F of x equals 1 over x. This is what the graph looks like for this. And it looks like that because as I get into the decimals that are less than 1, with a fraction smaller than 1, then it actually gets further away from 0, 0. Why, you hear me low? It's not loud enough. Is it better now? So, as I get the 1, 1, when I get to 1, it's going to be 1 divided by 1, which is 1. But as I get closer and closer to 0, my y value goes further and further up. Because like if I'm dividing by 1/2, 1 divided by 1/2 is 2. That's what I was trying to say back there when I went to the back of the room. Square root function, f of x equals the square root of x. Looks like this. As my x's get higher, so do my y's, but at a much smaller rate, which is what makes it curve downward. Square root of 1 is 1, but the square root of 4, when I get all the way out here, is only 2. So that's why it kind of curves off. Lastly is the cube root function. This looks a lot like the square root function, except that I also have a negative, because I can take the cube root of a negative number. Yes, you can. Because -2 to the third power is -8. So I can take the cube root of -8, which would give me -2. Duh. All right, well, that's the end of class. Thanks for coming today. Now we know what all the parent functions are that we're going to see. Tomorrow we're going to start going through the actual shifts and things that we do to the functions to make them no longer the parent functions. So hope to see you all tomorrow. Don't forget to like and subscribe. Ring that bell so you know when a new video comes out. And I will see you all tomorrow. Russell out.